right, welcome. So here are going to be the notes for Unit 16, the day 3 of the second half of this. A little bit of review on the area and circumference of a circle. Just a reminder, if you want to have it on that sheet, you can put it on there. So the area is pi r squared, and these are all multiplying. And over on the right side here, the circumference of the circle, it doesn't matter if you like 2 pi r, and these are all multiplying, or you prefer the circumference is equal to pi times diameter, pi d, or d pi. You decide. Just a little bit of a reminder here, the circumference of a circle is the perimeter. That's the perimeter of the circle. All right, so pulling in some stuff we did from the last unit, giving you the equation of a circle, x squared plus y squared is equal to 25. A little bit of review here, pull out the center and how much is the radius. So write that stuff down. And then if you're comfortable, go ahead and get the exact area of the circle in terms of pi and the circumference of that circle in terms of pi. All right, so center's at 0, 0. I square root 25 to get the radius because that's r squared. So I get the radius is 5. If I'm doing the area of the circle. Oh, in terms of pi, this means no decimal. So leave the pi symbol as the symbol. So pi times 5 squared. And typically when you see this, they'll leave the number in front of the pi. So when it says leave it in terms of pi, this is exactly what we're looking for. No decimal. Do not multiply the 25 and the pi out, and just leave it alone. The circumference here times 5. If you're ahead of me, fantastic. Just go ahead and keep going. Just double check to make sure we're good on these. And the exact circumference, so not multiplied out with pi, but exact circumference is 10 pi. All right, moving on to number 2. Pause if you need to. A tree trunk is roughly circular. A logger is using a tape measure to find the circumference of a cross section. So this means that if you look at a tree, it was chopped down, and you are looking at it from up above. So you are seeing like all the circles in the tree kind of thing. All right, so the cross section of it, so the circumference of the cross section, so the circumference going around it is 13 feet. What's the diameter? Okay, so anytime they're starting to tell you a formula, anytime they start telling you a formula, we're probably going to use that. This is the C, that's the total circumference. So if there's no pi in it, just leave the number as the number. So don't say 13 pi if the number is just 13. Circumference, this is 2 pi r. Divide by 2 pi and pi. Now, can't you just divide by pi? Absolutely, and get the diameter. I should be doing that, but I'm not. I'm just going to get the radius as well. So don't forget about just typing pi into your calculator. So if you're doing 13 divided by pi, make sure you type in 13, divide by, and hit the second button, blue button, and then the exponent key to get the pi in there. Make sure you're using that, not 3.14. Let's see. So to the nearest tenth, our radius comes out to be 2.1, and if you're already ahead of me, fantastic. The diameter is about 4.2, approximately. All right, so if you got all that, or if you need to pause, pause. I'm moving ahead to what we refer to as sectors and arc lengths. All right, so find the area of a shaded portion of a circle. So you see two circles down here. They have some shading in them, and that's a part of it that's shaded, so not the entire area. So I'm going to start first with the area formula. So the area for a whole circle is pi r squared. Now, if I figure out the whole circle, this is a whole circle, equals pi times 8 squared. So the whole circle would have an area of 64 pi. But, and I know you're already 2 steps ahead of me, totally fine. Because this is a diameter running through the center of the circle, and we only want half of that, we can take this and divide by 2. And we get 32 pi. I'm going to leave pi as the pi symbol. Did I forget? Oh, I forgot labels up here. Darn. All right, so sorry. Let me back up here. This is sweet. All right. So if I'm looking for half of a circle, I could do the whole circle and divide by 2. And when you do this, this is referred to as a sector, a section of it. A section or a sector is a section of the area. And as you're looking at the next one, I'm sure you can absolutely do that. Go ahead and do the sector of this one. So it's like a section. It's like having a circular pie or a circular, I don't know, lots of different things, cake. And going to it and cutting from the center and cutting out one of those pieces. It's like a pizza that's cut it through the center. So 36 pi would be the whole circle, but because I don't have the whole circle, I just have that section of it. It's in fourths. It's a fourth of the circle, actually. So the sector is equal to 9 pi. So if they're cut by a diameter, I divide by 2. If it's cut by, if you see 2 radii with a right angle in the corner, you divide it by 4. And this can also be done with the arc length or a piece, a highlighted or a piece of the circumference. This is referred to as arc length. So a sector is the section of area, whereas arc length is a piece of the perimeter of the circumference. And on this is highlighted. I know it's on your paper a little bit harder to see. You just want a part of the perimeter or a part of the circumference. So if you start off with the whole circumference and plug in your 8, then you get 16 pi. Well, if I only want part of it, I divide by 2, and this is actually referred to as the arc length. So the arc length is just referred to as a section of that. So if it's a whole circle, they refer to one thing. If it's a piece of it, they take it and refer to it as something a little bit different. It's based off the original of the whole thing for the circle. But they don't want to say, what's the circumference of that circle? And you're like, well, it's not a whole circle. It's just a part of it. So when they divide it up into pieces, they give it a new name. So the L stands for the arc length. The S, we're going to use S for sector. Pause if you want to. I'm going to move on to the next page. So a sector, again, is a section of a circle's area. Made by 2 radii and a central angle. and you had that up above. It was always made by 2 radii. One time it was made by a 90-degree central angle. The other time was 180 degrees central angle, so a straight angle. All right, so over here in the picture, you can see O is the center of the circle. You have 2 radii coming out. They're both length 12. And this is the sector. All right, so first of all, go through the old formulas, pause if you want to, get the area, circumference, and the area of the entire circle. Don't even worry about a part of it, but the entire circle. So go ahead and do that. 12 inches, so circumference. Pause if you want to. I'm just going to start throwing down some answers here. So exact is 24 pi inches. Let's see, if I multiply the 24 and the pi out, let's see, 24 and pi, I get 75.4 inches. So exact versus approximate or rounded. Area again. .144 pi is approximately 452.39 inches squared, because we're talking about area on here. Okay, and again, if you didn't pause, feel free to pause at this point and go back and work through those formulas, pi r squared and 2 pi r. Now, this is saying what portion or fraction of the circle's area and circumference are contained just in the shaded. So we're given a section with a central angle of 60 degrees. You don't have to redraw it. I just know it's starting to slide off my screen here. So I would take 60 and reduce that of the whole circle, 360, and this is 1/6. Okay, so using all these different pieces of information, determine the length and the sector in terms of pi into the nearest hundredth. Okay. So I'm just focused on this little wedge now. So for the sector, I'm going to use this. I have 60 degrees out of the 360 times 2 pi r. Was it 12? Which you already did up above is 24. And the arc length, I'm also writing down. The fraction I have is this. Oh my goodness, back that up, come on. Sorry, back that train up. I was reversing it, I apologize. 2 pi times 12, there we go. And the sector is pi times 12 squared. All right, if you're gonna do exact, you're gonna type in everything except the pi button. So for the sector, I do 60 divided by 360 times 12 squared. And I will get, for an exact answer, I get 24 pi. Rounded to the hundredth, if I do 24 times pi, I get about 75.4. Okay, so this is just how much area, just weird, there we go. How much area is in just that piece, and it's coincidence that it is the circumference as well. That's just how the numbers work out. The length, 60 divided by 360 times 2 and 12. This is 4 pi. Exact is 4 pi and rounded is approximately 12.57 inches. All right, so the general form, and again, if you need to pause, pause. The general form for the area of a sector and for the arc length. Sector, I'm going to use capital S, and this is area. Arc length, I'm going to use a capital L. That is for the perimeter. A sector is whatever, so the angle measure, you can see an angle over here is theta. 3 pi or degrees over 360. And this is for the central angle. So that's the central angle. So you're figuring out what fraction of a circle it is, and times pi r squared. The arc length, the piece of the perimeter, or the piece of circumference, is again that same angle measure, or whatever angle measure it has, times 2 pi r. Now at this point, you may want to stop this and grab that. You took a piece of paper to grab that formula, to making that formula sheet, you might want to transfer this information over, so you have it in both spots. If you haven't started making that, that's okay. Just remember, you're going to have to make your own formula sheet for the next test. All right, and when you're ready, feel free to go on to these and double check them. I will post all the answers online for you. I'm going to run through this first one for you, but then I'm going to post the rest of them online, just so you can check your answers. Okay. Give the area of the shaded sector and the arc length. Okay, so the shaded part. So there's your angle. So there's theta. 270 out of the whole circle is 360 times pi times 10 squared. Give your answer in terms of pi. So I'm going to type that in a second. Arc length starts out the same exact way, except it's times 2 pi and 10. All right, sector 270 divided by 360 times 10 squared. So I'm leaving the pi out of it when I'm using the calculator. Centimeters squared. Again, 270 divided by 360 times 2 and 10. 15 pi centimeters. Okay, same format. Try letter B if you're like, oh, yeah, I think I got this. Pause, try letter B, and then check the rest, see how it goes. All right, so sector on this one's 135 by 360 pi times 16 squared. Arc length is 135 divided by 360 times 2 times pi and 16. 360 times 96 pi in centimeters squared. All right, so just double check the rest of them as you go. If you have questions, feel free to message me and let me know. Otherwise, I'll see you next time.